We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
I welcomes you in the 4th lecture of Unit number 2, Road Materials and its Construction Aspects, in the subject Basic Transportation Engineering. We cover first topic road pavement, second topic stability of road pavement and soil stabilization. Today we see the third topic materials used in road pavement and its test. The subtopics are coarse aggregates, grit and bitumen. Flexible pavement off-road transfers the wheel loads on the soil subgrade by deformation action. This deformation action is due to movement of coarse aggregates in base course, which are mechanically interlocked by rolling. So the load is absorbed in the joints of coarse aggregates. This is reason why flexible pavement takes more load compared to rigid pavement. After rolling off large sized coarse aggregates, voids are filled by grit using water spray, which is known as screening. The voids remains after screening are filled by stone dust slurry, which is known as binder. Bitumen with grit is used to get smooth top layer. First road material is coarse aggregates. The test on coarse aggregate is classified as size test and strength test. In size test, aggregate grading test is carried out. Other test is flakiness and elongation test, but nowadays this test is eliminated. In strength test, different tests are carried out for strength of coarse aggregate. First is aggregate impact value test. Second is aggregate crushing value test. And third is aggregate abrasion value test. In size test, grading is done by sieve analysis. We see a table for grading 1. For grading size 90 to 40 mm, 5 sieves are taken for sieve analysis. The sieve size is 100 mm, 80 mm, 63 mm, 40 mm and 20 mm. Percentage passing by weight is shown against sieve size. This table shows sieve analysis for grading size 63 to 40 mm. The sieves taken for this size are 80 mm, 63 mm, 50 mm, 40 mm and 20 mm. And percentage passing by weight is shown in third column against sieve size. This table shows sieve analysis requirement for grading size 50 to 20 mm. The sieves taken for this sieve analysis is 63 mm, 50 mm, 40 mm, 20 mm and 10 mm. Percentage passing by weight is shown against sieve size. Strength test on coarse aggregate. When vehicles wheels passes on road pavement, the aggregates in base and subbase course suffers impact load continuously. When vehicles starts or stops, the aggregates in base and subbase course suffers crushing load, that is gradually increased load. When vehicles load transferred to soil subgrade, the movement of aggregates suffers abrasion load. Indian Standard 2386 1963 in part 4 mechanical properties, methods of test for aggregates for concrete. In this code, different tests for aggregates are standardized. Determination of aggregate crushing value, determination of aggregate impact value, determination of aggregate abrasion value. First we see aggregate impact value test. This is apparatus used for impact value test. Cylindrical cup is shown. Hammer of weight 13.5 to 14 kg weight is shown. The apparatus required for this test are IS sieves 12.5 mm, 10 mm and 2.36 mm. Cylindrical measure 7.5 cm diameter and 5 cm height, which is used to measure the sample. Tamping rod 10 mm diameter and 23 cm length, used for compaction. Cylindrical cup and impact testing machine and balance. First step is take oven dry coarse aggregates which are passed through 12.5 mm size sieve and retained on 10 mm size sieve. Fill the cylindrical measure in 3 layers, compacting each layer by 25 strokes using 16 mm diameter steel rod and weight on balance and noted as W1. Fill the cylindrical cup, level the top surface of aggregate and put in testing machine. Apply 15 blows of 14 kg hammer from 38 cm height. Sieve the broken aggregates in 2.36 mm size sieve. Weight the passed aggregates and not as W2. Repeat the procedure 2 times more, keeping the W1 constant. Find the impact value in percentage for all 3 samples and take average to give final result of aggregate impact value. Calculation. Aggregate impact value is W2 divided by W1 multiplied by 100. Quality standard given in Indian Standard 383 2016. According to this standard, for aggregates to be used in concrete for wearing surfaces such as runways, roads, pavements, tunnel lining, carrying water, spillways and stealing basins is maximum 30%. That means for aggregates which are used for road construction, maximum impact value should be 30%. Lesser the impact value, it is better for road construction. For aggregates to be used in concrete other than for wearing surfaces is maximum 45%. Also, they highlights for concrete of grade M65 and above, maximum aggregate impact value is 22%. To understand this test, you can use YouTube and the video prepared by NITR NCTEL. Other is video prepared by A. Mohan. Now the second test on coarse aggregate crushing value test. In figure, a metal cup, aggregates are filled and from top load is acting through plunger. The size of cup is shown. Apparatus. Indian Standard sieves 12.5 mm, 10 mm and 2.36 mm. Cylindrical measure 11.5 centimeter diameter and 18 centimeter height. Test mold 15.2 centimeter diameter and 13 centimeter height. Tamping rod 16 millimeter diameter and 45 to 60 centimeter length. Compression testing machine and balance. Cylindrical measure is used to measure the weight of sample. Procedure. Take oven dry coarse aggregates which are passed through 12.5 mm size sieve and retained on 10 mm size sieve. Fill the cylindrical measure in 3 layers, compacting each layer by 25 strokes using 16 mm diameter steel rod and weight on balance, not as W1. Fill the mold, level the top surface of aggregate and put in testing machine. Apply crushing load on aggregates gradually by plunger so that in 10 minutes it reaches at 40 ton. Then release the load. Sieve the crushed aggregates in 2.36 mm size sieve. Weight the passed aggregates and not as W2. Repeat the procedure 2 times more, keeping the W1 constant. Find the crushing value in percentage for all 3 samples and take average to give final result of aggregate crushing value. Calculation. Aggregate crushing value equal to W2 divided by W1 multiplied by 100. Quality standard. According to Indian Standard 383 1970, the aggregate crushing value shall not exceed 30% for concrete used as wearing surfaces such as runways, roads and pavements, and shall not more exceed 45% by weight for other than wearing surfaces. In 2016, they says for aggregates to be used in concrete for wearing surfaces such as runways, roads, pavements, tunnel lining, carrying water, spillways and sealing basins, 30% maximum. But for aggregates to be used in concrete other than for wearing surfaces, they says in case the aggregate crushing value exceeds 30%, then the test for 10% fines should be conducted and the minimum load for the 10% fine should be 50 kN. The third test on coarse aggregate, aggregate abrasion value test. A cylinder or drum used for this test is shown. Steel balls are shown. The movement of drum is shown. The balls are in contact with coarse aggregates and the abrasion effect is generated. Apparatus. Indian standard sieves 12.5 mm, 10 mm and 1.70 mm. Los Angeles testing machine, that is closed drum having diameter 70 cm and length 50 cm. In table 2, grading of test samples, there are different gradings are shown. Grading A, B, C, D, E, F and G. For grading A, 4 different weight is shown. Each is 1250 grams. The total is 5 kilogram. 40-25, 25-20, 20, 12.5, 12.5 to 10. So for grading A, we use aggregates which are passed through 40 mm size sieve and retained on 25 mm size sieve is 1250 grams. Aggregates passing through 25 mm size sieve and retained on 20 mm size sieve 1250 grams. Aggregates passing through 20 mm size sieve and retained on 12.5 mm size sieve 1250 grams. Aggregates passing through 12.5 mm size sieve and retained on 10 mm size sieve 1250 grams. In this manner, for different grading, we have to use different size aggregates, but the total weight is around 5 kilogram. For these gradings, number of spheres are different and the weight of sphere is known as weight of charge. For grading A, 12 spheres are used and weight of charge is 5000 gram or 5 kilogram. For grading B, 11 spheres. For grading C, 8 spheres. Grading D, 6 spheres. For E, F and G, 12 number of spheres are used. Procedure. Take about 5 kg oven dry coarse aggregates which are passed through 12.5 mm size sieve and retained on 10 mm size sieve and not as W1. Fill these aggregates into the Los Angeles testing machine. Keep steel balls in machines 4.8 cm diameter and 390 to 445 grams weight. Revolve the drum for 500 times for grade A, B, C and D at the speed of 30 to 33 revolution per minute. For grade E, F and G, revolve the drum for 1000 times. Collect the abrased aggregates and sieve in 1.70 mm size sieve. Weight the passed aggregates and not as W2. Repeat the procedure 2 times more, keeping the W1 constant. Find the abrasion value in percentage for all three samples and take average to give final result of aggregate abrasion value. Calculation. Aggregate abrasion value is equal to W2 divided by W1 multiplied by 100. Quality standard. According to Indian Standard 383/2016, for aggregates to be used in concrete for wearing surfaces such as runways, roads, pavements, tunnel lining, carrying water, spillways and stilling basin, 30% maximum. For aggregates to be used in concrete other than for wearing surfaces, 50% maximum. Now, the second material for road construction is grit. In gradation test of grit, two sizes are shown in this table. First is A 12.5 mm size and second is B 10 mm size. For both size of screening, the sieve size used and percentage passing by weight is shown. Third material is bitumen. It is obtained by fractional or physical separation distillation of petroleum crude in refinery. That means bitumen is a product which is obtained by refining of crude petroleum. Bitumen is a solid or semi-solid hydrocarbon material which is black in color. It melts when heated and it is completely soluble in carbon disulfide and carbon tetrachloride. When bitumen contains some inert materials or minerals, it is called asphalt. Tar is a viscous liquid obtained by destructive distillation of natural organic materials like coal, wood and oil in the absence of air, used for road patch repairing work. Destructive distillation means chemical changes are occurred. In fractional distillation, no chemical changes are occurred, only physical separations are occurred. Indian Standard 2013 is used for paving bitumen specifications. In fractional distillation of crude oil, furnace is shown and at different temperature different products are generated. From top, petroleum gas, gasoline, naphtha, paraffin, diesel, fuel oil, lubricating oil and bitumen. Comparison of bitumen and tar or asphalt and tar. First comparison point, carbon content. Bitumen or asphalt have less carbon content and tar has more carbon content. Comparison point setting time. Bitumen or asphalt has less setting time and tar has more setting time. Comparison point hardens. Bitumen or asphalt hardens slowly and tar hardens quickly. Comparison point adhesiveness. Bitumen or asphalt has less adhesion and tar has more adhesion. Comparison point cost. Bitumen or asphalt is costly and tar is cheap. Comparison point is durability. Bitumen or asphalt is more durable and tar is less durable. Other forms of bitumen used for small works of road construction. First form is cutback. When bitumen's viscosity is reduced by a volatile diluent, it is known as cutback. Cutback bitumen is used only when surface of road and aggregates are dry. Based on diluent, types of cutbacks are RC. RC means rapid curing cutback, that is naphtha and gasoline is used as a diluent. MC means medium curing cutback and oil is used as diluent. SC is slow curing cutback and kerosene is diluent. Second form is emulsion, a liquid product obtained by vigorously stirring up a mixture of two unmixable liquids. It is known as emulsion. In an emulsion, one liquid is dispersed in the other in form of fine globules or droplets. Bitumen emulsion is obtained by vigorously stirring up a mixture of asphalt or tar particles of size 3 microns and water in the presence of emulsifying agent, that is soft and resinous substance about 1%. Emulsion contains about 55 to 65% bitumen by weight. Emulsion bitumen is used in all weathers. Grades of bitumen. From 1950 to 2005, old gradation based on penetration value of bitumen is used in India. In 2006, new gradation based on viscosity is standardized. Old grades of bitumen according to penetration value. 6 grades are shown: S35, S45, S55, S65, S19 and S200. For S35, penetration value is 30 to 40. S means straight run bitumen, not blended, neither modified. In Indian Standard 73 2013, requirement for paving bitumens are penetration at 25 degrees centigrade, minimum penetration for grade VG10 is 80 mm, For VG20 60 millimeter, for VG30 45 millimeter, and for VG40 35 millimeter. VG means viscosity grade. Absolute viscosity or dynamic viscosity measured at 60 degrees centigrade in poise. For VG10, absolute viscosity, dynamic viscosity is 800 to 1200 poise. For VG20, 1600 to 2400 poise. For VG30, 2400 to 3600 poise, and for VG40, 3200 to 4800 poise. Kinetic viscosity measured at 135 degrees centigrade in centistokes. Minimum kinematic viscosity for VG10 grade of bitumen is 250 centistokes. For VG20, 300 centistokes, VG30, 350 centistokes, and VG40, 400 centistokes. Flash point measured in open cup, minimum 220 degrees centigrade for VG10. All viscosity grade have minimum flash point 220 degree Celsius or centigrade. Solubility in trichloroethylene in percentage, 99% minimum solubility in trichloroethylene for all grades. Softening point, ring and ball apparatus measured in percentage, measured in Celsius, minimum 40 degrees Celsius for VG10, 45 degrees Celsius for VG20, 47 degrees Celsius for VG30, and for VG40, 50 degrees Celsius. Test on residue from rolling thin film oven test. First is viscosity ratio at 60 degrees centigrade. Maximum viscosity ratio. Viscosity ratio is a ratio of viscosity of bitumen which are processed to bitumen which is in original is 4 for all grades, which is maximum. Ductility measured at 25 degrees centigrade, measured in centimeter, minimum 75 centimeter ductility for VG10 grade, minimum 50 centimeter ductility for VG20 grade, minimum 40 centimeter ductility for VG30 grade, and minimum 25 centimeter ductility for VG40 grade. So this table of Indian Standard 73 2030 for road construction in India, requirements for paving bitumen. So today we see the road materials and its test. We see coarse aggregates, grits, and introduction of bitumen. Thank you.